Hello. Hello everyone. Can you hear me? If you can hear me, can you all please just type in into the live chat section so I know that you guys can hear me? Now it's fine. Okay, cool. Can you guys hear can you guys see my screen? Cool. I don't know what robot I have in the back, but yeah, okay, cool. Okay, let's start. Yeah. So my name is Puneet Agrawal and I work for Microsoft and I will talk about how Ru was created. Okay. So I will talk about artificial intelligence in general, and in particular, I'll also touch upon how Ru was created. Okay. So some housekeeping before we start. So first of all, please go to this URL and let me know which college year you are in. Just type in into Ru which college year you are in, and I will aggregate those results at backend right now. So I'm just giving 2 minutes for you guys to do that. The link is on the screen. You can't see the screen. Link is on the screen. Go to m.me/ru and then tell which college year you are in. Yeah, it's a Facebook link. Just write one for first year, two for second year, and so on and so forth. So again, I'll just type it in here on the chat itself. Go to this link. Yeah. Okay. Some people have already responded. It's kind of like a mixed crowd. So I'll just, it's kind of a mixed crowd here, and I would try to cover the basics as well as try and talk about some deep concepts, but it's not always possible to kind of have everything together. So bear with me if you think that some of the things are not as per your level, and if there is something which is not if there is something which you do not understand, stop me at any point in time and ask the question, and I'll continue to look at the questions and then try to answer most of them. Yeah. So let's talk about some of the expectations that you guys have. So can you type in into the comment section, few of you, what were you expecting when you kind of attended this session? What were you thinking when you thought that we'll go and attend this session? What were your expectations? Just type them in into the comment section. Okay, someone is saying they are fan of Ru. Someone said they had no expectation. Let's see what other people say. Come on, type in some things. What were you expecting when you um, thought you would attend this session? Okay, a brief knowledge about AI, how to build AI, overview of hot concepts, overview, wanted to get an idea, curiosity. Okay, 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 okay. Cool. Yeah, great. Thank you so much for your input. That really helps me. So, in this session, I would cover some of the overview of what AI is and some of the applications, as well as a little bit about how RU is getting built. I just want to set one expectation, however, that do not expect that you can learn AI in 1 hour. I'll give you an overview, which will hopefully provoke you to learn more about it and understand it in a deeper way. But you cannot learn whole of AI in 1 hour. I have been working in this space for almost 10 years now. There are a lot of things which I don't know still, and I keep learning every day. So just understand that you cannot learn AI into in 1 hour. I will. Some people also said that they wanted to learn about RNNs and CNNs and those kind of things. I will not go into a lot of detail into these algorithms in this session. They are fairly advanced topics, and given the kind of wide range of audience that we have, we need to set the basics right, and then only talk about some of these things. Um, so. First of all, I want to kind of emphasize that I will talk about a lot of concepts, and you need to really go back and think about those and drive your own meaning. In terms of like AI, I think it's important to understand how the behavior of AI is, and it's not always like deterministic, and there are a lot of principles that you have to apply. So it won't be like a regular kind of lecture where I'll tell you that okay, A, B, C, D, and then go do these things, and it will be do those things and it will work. I think I'll talk about a lot of like real life concepts, and then I would really urge you to go back and think about those concepts and what does it mean for you, right? Again, like I think we already have a pretty engaged audience, but like do ask questions. Um, if there is anything that you think that at any given point in time you want to ask, just ask those questions. Um, okay. Yeah, sorry. So I think like a lot of people are asking questions. Um, so I would urge you if you could reduce the amount of noise on the chat, because that way, if there's a question that you want to ask with respect to the presentation that I'm doing, then I can take a look at that and answer that. Otherwise, I might just miss it out. Um, so if you think that whatever questions you're asking, you could ask later on, just hold on to that and try to ask questions which are pertaining to the slides that I'm on at any given point in time. And in the end, I would request you all to provide feedback. The feedback is very important for us to understand how it happened and what can be changed for future, right? Cool. So today we will cover what is AI. I'll talk about what does a human-like AI mean. It's a pretty interesting concept coming up newly. So how does human-like AI work, and what does it mean, and so on. I'll talk about some interesting capabilities in RU and how they are deep machine learning and AI problems, and a little bit of a peek into one aspect of RU's implementation. Okay. So, what do you guys think AI is? Can you just type in again in the comment section some thoughts on what do you think AI is? I'll wait for you guys to type in. Somebody is saying they are adaptable programs. Yeah, more questions. Man-made brain, learning from previous events, automating any task, learn without algorithms, a process of learning from machine. Cool. Yeah, that's nice. A lot of good answers there. Thank you. So in general, like the movies and the Hollywood movies in particular have kind of made AI like a cool thing. So this is what comes to my mind when I think about AI. Something which is many many years away from today. Something which is moving. Something which is just like a human. And that is what comes to my mind. But perhaps. AI is not so far in terms of time. AI is not like 20 or 30 years away from us. AI is perhaps just around the corner and it is there to kind of for us to interact with and in our lives always. So, this is how Wikipedia defines AI. Wikipedia says that AI is a field of research that defines itself as a study of intelligent agents, any device that can perceive its environment and take actions that maximize its chance of success at some goal. So, how many of you use search engines? I guess every one of you use a search engine. Is search engine an AI? Perhaps search engine is an AI. It kind of takes actions. When you search a query, it would take an action that will maximize your chance to find the relevant results. Same holds true for many of the agents or bots we all have in our phones, whether it be Cortana, Siri, um, or Google Now. All these devices or all these agents uh, take in a user query, kind of try to understand what that means, and then output, which by doing that they're trying to maximize the chance that whatever intent you had gets satisfied. So AI is around us every day, and I think not just in terms of programs, you would also see it in terms of devices. Like for example, in my office at Microsoft, when I walk into the office, the light automatically goes on because it detects some motion and it kind of thinks that it's best to turn on the lights. So that is an AI in some sense. Even like many of you might be using things like Netflix, so it would recommend you new movies that might be of interest to you. That is AI. So I think AI is almost everywhere around us. It is not something in a nutshell, it is not something which is many many years away, but it is something which is impacting us every day. We just don't realize it. It just need not be this beautiful big robot which is walking around your house. It can be anything small, anything big. It could be anything which is basically looking at the environment and taking actions such that whatever goal that it is designed to achieve, the chances of its success are maximum. Any questions? Yeah, somebody says Wiki from Small Wonder. Yeah, so I think like Wiki was an excellent example of AI, but perhaps it kind of also indicated that AI is like far off, many many years away from us, which is not exactly true. AI is definitely around us and it is helping us. Any questions anyone has at this point? Something that they would want me to know? I'll just wait if there are some questions. Okay. So I think like a lot of people ask what's the difference between AI and machine learning. I think AI is in general a broader field of research which kind of indicates the definition that I just talked about. Machine learning is a part of it. Machine learning kind of can be defined in a way that how can you take some data and how can you mimic whatever behavior is defined in the data when a new data is seen. So let's say that we want to learn a classifier which classifies whether a query is finance query or not. So, for example, does it have a finance intent, Microsoft stock price, Google stock price, those kind of things. So, um, a machine learning algorithm will look at a lot of queries which are of finance intent and learn to differentiate them from other queries which are not finance intent. So that is a machine learning algorithm. It is specifically doing a task of learning from data and outputting something. AI is a more broader perspective. Um, Someone also asked if they need machine learning to do AI or not. I think like I will want to kind of say that uh, I think the understanding of any problem, like you will understand as a human being, is important. Uh, you should have an intuition that what kind of data would you use, what kind of features would you use to solve a problem. That is important. You need not have a lot of deep mathematical understanding, but you should be able to think that what kind of data is needed to solve a particular problem. Like, for example, I just talked about a finance classifier, right? So if there's a finance classifier that you need to build, then what kind of queries will you take, what kind of issues there might be, and those kind of things. You have to just think about those things in your head, just as a human would do. How would you as a human say that a particular query is finance or not? Think about those aspects and then try to learn those aspects in the machine. I think that part is very important, and that is something that will always help you in creating systems which are good systems. So I'll just move forward. Um, I'll now talk about what is human-like AI, right? I mean, I talked about AI, but what is a human-like AI? So let's look at this quote from Alan Turing, which he gave in 1950. So Alan Turing said that a computer would deserve to be called intelligent if it could deceive a human into believing that it was human. We are obviously not there. We are far from achieving that goal. Um, but we have made progress. And in this upcoming slides, I'll talk about some of the aspects of a human like AI, which makes it more closer to what a human would behave like. So let's look at this video. So that was one nice video that I wanted all of you to hear. This is a beautiful example of how AI can be more human-like. If you look at this program that these guys have built, what they have essentially done is that they have taken a algorithm, a program, a machine, which can mimic the behavior of what an eye can do, right? Just like we all can see. Can you create a program which can see? I think that is what this video showed. And I want you to know and kind of like point out very specifically that it is not that many of these technologies or algorithms didn't exist. A lot of these things already existed. Just that we kind of brought them together so that uh, we just brought these things together to kind of achieve something with a specific purpose of mimicking how an eye would behave. So they were always uh, object recognition techniques were always there. We could always identify objects. That has been a pretty big area of research in past. We would also understand emotions, but bringing all of them together in a there was always ACR, OCR, sorry, which is recognition of text. But bringing all of them together in an application which kind of serves a purpose is what perhaps the human like AI behavior is. Let's look at some more examples of this. So let's say that if I ask you, do you like chocolate? How would you respond? You might say yes. Then if I ask you again, do you like chocolate? You might again respond yes. And then if I ask you again, do you like chocolate? You might respond again with yes. But then if I keep asking you, do you like chocolates again and again and again, then how would you perhaps react? You might just say that, oh, I'm fed up. Why are you asking me the same question again and again? And so on. I think that is how humans typically behave. This is a small example of how uh, humans behave, which is different from how AI of today behave. For example, let's say a Google search engine, right? Or any search engine for that matter, or any agent like Cortana or Siri for that matter. If you ask them a question, do you like chocolates? They will give you a web result or a response. And they will continue to give that same response over and over again because they're programmed to do that. What they're programmed to do is that given an input, they will give an output which is the most relevant. That is what they are programmed to do. But that is not how we humans behave. You might give the right answer in the first time, in the second time, but then you would say that why are you asking the same question again and again? So a human-like behavior would perhaps look like this. So if you say, "Hey, do you like chocolates?" They say, "Yeah, I love chocolates." And you ask again, do you like chocolates? Yeah, you may say, you may rephrase it. You may say, chocolates are my favorite. But if someone asks again, do you like chocolates? The person might just say, oh, I already told you. Why are you asking me again and again? So I think this behavior, which kind of understands that the question has already been answered and doesn't need to be answered, is a very, very small, a really small example of how AI can move from being deterministic in terms of given an input, giving an output, to kind of understand how humans behave and change its response based on the conversation that is happening. So I have one more video, but I think there is some issue with the voice, so I will skip this video for now and move on to the next slide. Um, so we all kind of evolve and learn and keep growing, right? I mean, every day we learn something and continue to move to learn new things and kind of reflect upon what we did or what we saw and kind of keep learning. That is how we would hope that an AI or an uh, AI robot or AI bot or AI system would also behave. So let's say that you went to this chatbot and said, "Hey, what's up?" You might get a response with something like, "Studying right now, have an exam tomorrow." Um, And then you might say, okay, the chatbot might say, okay, study well, all the best, and then you might say thanks and go out. But then when you come the next day and say hi, then you would expect that uh, your friend, just if it was a human, would ask something like, how did your exam go? That is what we think an AI should also do. AI should learn and kind of respond according to what it has already learned. So it should kind of, your relationship with an AI should grow over a period of time. AI should know you better over a period of time. That is what we think in human like AI should do. Um, when you start a friendship with some of your friends, you don't like always start from ground zero. You talk, you know what are their likes, what are their dislikes, what is their name, what is their age, what they do, what are their hobbies, what their parents do, and so on and so forth. And you build upon those conversations. You don't start always from ground zero. You don't always say, oh, what is your name? Every day you don't ask that question. You kind of build upon that. So I think that is what an AI should do. It should build upon what it has already learned and kind of learn new things and continue to grow that relationship. This this has two aspects. One obviously is memory, like to know and store what has already happened. And second is how to interpret from the memory, right? For example, if um, somebody said that my birthday is on 5th of June, then a memory would store that birthday and 5th of June. But then interpreting something from that and kind of like using that data is another aspect. So the example of that would be that when 5th of June comes, the AI would wish you, oh, happy birthday. So that is an example of how you will use that memory or use that content and wish a person something. So again, like this is very important and key aspect of AI, that AI should learn and grow over a period of time. Then the last point that I want to talk about is being able to understand emotions. So just consider this example on the screen right now. It says user came and said, just had a breakup, I'm feeling so low. And the chatbot or the agent responded, I can't understand what you just said. Type help to know the command that I follow. Compare this with this example on the right now. Just had a breakup, feeling so low, and the AI comes and says, "Oh, I understand breakups are painful. Should I play a nice song for you?" So, ability to understand emotions is something which is going to be one of the most key aspects of how robots will behave. The empathy or understanding of emotions is what will differentiate humans from AI as we go forward. It is a very challenging problem. It is not something that can easily be solved, but it has to. We have to make progress in this direction. If chatbots or robots are not going to be able to understand the feelings or emotions, then they might turn out like insensitive or rude, and may not be able to establish a deep connection with their users. So you might think that, like, why do someone need to come and talk about their emotions to an AI? But there are these some real examples that we have seen in our logs, where people have tried to express their emotions, come out and pour their heart to our AI. So some of the examples are, oh, I have an exam tomorrow, I'm so worried about it. My uncle is in hospital, something is with his brain. I'm lonely today. I want to propose a boy, but I am shy. It is so sad that India lost today, and so on and so forth. So there are there's a basic human trait to express emotions, and then when you chat with a chatbot, you expect that they will reciprocate and understand those emotions and respond appropriately. So understanding emotions is one of the most important pillars of what will make an AI human like, and hence I wanted to point out these three examples of what a human like AI could look like. There are various other aspects. Someone mentioned Wiki earlier, right? Ability to walk, move around, ability to speak in a voice which is more human like, and so on and so forth. So there are various aspects. I just wanted to point out some of the examples of how small things like when you repeat a particular query to the robot or to AI or to chatbot, they can say that, oh, I have already answered that. Small examples of how AI can become more human like. So why do we need a human like AI? I'll stop here for a couple of minutes and would like to hear your views on why do you think that a human like AI is needed in today's world. So we're just waiting for people to type in why they think that a human like AI is needed. So I think some of you have started answering. People are saying that it's for easiness or to understand the emotional aspects, to serve the companion, they are trustworthy. Thus, people like to share the problems with them instead. Sure. So I think you all kind of like hit upon very nicely on the need for a human like AI. To sum it up, I would say that essentially um, any component, any machine, anything in our surroundings, if behaves like a human, then it is likely to establish a better connect. It is likely to establish a deeper connection with the user. So I think that is the essential fundamental reason why we think that we would need human like AI. So now, like moving on to the next segment. Let me introduce Rue to you guys. So this nice collage of things that you see on screen in many ways kind of represent what India is. Colorful clothes, festivals, dance forms, streets, foods. That is what kind of represents India in many ways. And that is what we've tried to build to be a cheerful and colorful personality, something which is for India and represents the culture, the spirit of India in many ways. So Ru was launched in February 2017 this year, about 9 months back. And Ru has had more than 17 million conversations to date. It is very interesting to know that many of the users chat for Roo for more than 10 hours. So when I started building Roo about 2 years back, I used to ask myself this question that why do we need to have something like Roo? Everyone have their own friends. They would talk to them. Why would they talk to a chatbot? Why would they talk to Roo? But now, like after 9 months of its launch and having seen several examples, I'm actually quite amazed at how much people want to talk, and they share almost everything with Rue now, and it just behaves like a friend, like a companion to most people. That is our promise. Our promise is that whether you just want to talk about your exam or you want to share some good news with it. Rue is always around. Rue is there to chat with you. I think that is the promise that we have. Um, and that is a small like introduction to Rue. And I will now move on to some of the capabilities of Rue, which are very interesting in my point of view. I'll touch upon three capabilities of Rue in this session today. Um, First two, I won't go into the detail into how. Um, I will not go into the detail of how these are implemented, but in the third one, I'll go into a detail of how we have implemented and give you a sense of how does some of the features of Blue work. So first, let's look at understanding emotions and look at this example, right? So someone says, I texted you last night. The other person said, sorry, I saw your text now. And then the first person again says, why don't you ever text me? So what do you think is the emotion of why don't you ever text me? The emotion of first person who typed, why don't you ever text me? What do you guys think is the emotion of this sentence? Is it sad or is it angry? What do you guys think? Okay, some people say anger and sad. Is this getting scary for someone else as well? Loneliness, frustrated, sad, little angry, heartbroken, angry. So clearly, like I think there are two kind of things that people are talking about, right? Some people think it's angry, some people think it's sad. Now, if I say something like this, I texted you last night. Sorry, I saw your text now. Why don't you ever text me? So when I say that, why don't you ever text me? Clearly, it's an anger, right? So that is what is one of the challenges in understanding emotions. Without having voice, without having human expressions like facial expressions, it is always difficult to. It many a times is difficult to understand what is the emotion. So understanding emotions in text is a very difficult problem. And we are on a path to try and understand some of these emotions. I can't say that we have solved this problem completely, but there are few examples that you can try out right now in Rue and see how she responds. So I'll invite you to try out. I'm nervous about exam on Rue and see what she says. As I said, while you guys try out, let me give you a bit more context. As I said, understanding emotions in text is a very difficult problem, and it is also one of the kind of issues which are very sensitive. When a person is kind of angry, sad, and comes and talks to you about it, as a product or as an AI chatbot, you really want to listen to that person, console that person, and just ensure that they go away happy, right? Um, so I hope many of you have already tried this out. Let me go ahead and show you what did she say. So she said, "Take a deep breath. You got this. Don't stress yourself out." This is exactly what you hope, like your friend would say. Give you a little bit of hope, console you, and basically encourage you to go ahead and crack the exam and not really stress it out. There's one more example I would like you guys to try out. So someone says that I started new job today, and see what um, the Ru says. We'll just wait for 30 seconds for this one. Hope you can quickly try this out. What Ru said was that, oh, good luck, congressman. How did your first day go? Again, this is something that you will expect from your friend. You would expect them to kind of like ask about your job and acknowledge that it's a happy moment for you by saying congratulations. Again, I think there are a lot of learnings on this field. I don't think that we have solved this problem completely, but we do hope that by trying to understand more and more emotions, more and more scenarios which people talk about, we would be able to understand users better, respond more appropriately, and establish a deeper connect with the user. Now let me talk about one more example. So somebody actually on the screen is asking, can uh, we produce like a meme? Um, and of course, yes, we can produce a meme. But I'm going to talk about a very interesting scenario where Roo can paint. So I would invite you to go ahead and try out Do You Paint on Roo and see what Roo says. Uh, Try it out, it is very interesting. And then I will show you uh, some examples. But I'll invite you to try out Do You Paint. In the meanwhile, I'll look at some of the questions and try to answer them. So some people talked about NLP. So let me quickly give you a brief thought on how NLP helps. So natural language processing, NLP stands for natural language processing. So I think the NLP kind of helps us understand what are the intents and entities um, in the utterance. So that helps. Um, that helps kind of understand the intent primarily. But you need to kind of do a lot of analysis on top of NLP to be able to understand emotions, for example. NLP, in some sense, is a building block that will help you create more interesting scenarios. Um, so, some people have tried Do You Paint, and then they are responding that she was able to paint. Um, so someone also asked question, what is intent? So I think the intent is something like um, I am hungry. Then your intent is to look out for food, right? If you say that what is the weather outside, then your intent is to know temperature, to know climate. If someone says I am feeling sad, then their intent is that someone would console them. So I think the intent is typically a broad word, but typically it is used to um, understand why are you saying what you are saying and what do you want to achieve uh, by saying what you are saying. So I hope many of you have tried Do You Paint on Roo. Um, so let's see how. So if for those who have not tried it, this is an example of an elephant, and let's see how Roo paints it. So Roo was able to generate this beautiful color scheme for the elephant, and there are many more examples like this. So behind the scenes, what is happening here is that Rule has looked at thousands and thousands of images and paintings, and it has learned like what are the color schemes that work best uh, with each other, such that it. So, what are the colors that work best with each other, and then use those colors to paint some of these pictures. So that is what Rue has done in this example. Both how to understand emotions as well as how to learn to paint are perhaps like each a topic of 1 hour. So I'm not really going into these details. I wanted to give you a sense of what kind of capabilities today AI can achieve. AI can understand emotions, AI can learn to paint, AI can even write poems. So we are really making a leap forward in terms of the capabilities of an AI. Many years back, if you would think that many years back, you would think that um, how will AI behave, or I mean, only humans can paint, or only humans can draw. But that is not true anymore. AI is able to today kind of like take many of these creative tasks as well, and is able to do that. So let's now dive into the third aspect and go deeper into how it works. So, do you guys wonder how Ru can answer everything? Like whether you ask, do you have a boyfriend, or you ask, uh, what are you? It would be able to answer almost anything and everything at all, right? So let's try and understand how this works. And this is a brief overview of the architecture. So suppose that we have a very, very big repository of sentences that are said by humans. We call it index. So we start by a user query, and we retrieve the most relevant response from the repository for a query, and output that back. So basically, this is a very, very simple architecture overview of how Ru is able to answer all the questions, right? Um, Again, to repeat, there's a very big repository which we are calling the index, which has a lot of answers. We get a user query, match what is the most relevant answer for the query, and output that answer. So it's a very simple system. The repository of responses is called index, and the algorithm that gets the best output is called the ranker. Now, let's see how the index is created and how the ranker is created, which are the two key components here. So, how do we build a good index is the first question, right? And this simple, it looks very simple, like you will have a bunch of uh, uh, things in your index, but there are a lot of challenges which I'll talk about. So we look at in to build the index, we look at data from Twitter, from Reddit, from Quora, from Yahoo Answers. Sorry, there's a spell mistake here. It is Quora. Um, so what an index is basically doing is that if someone is saying what are the best travel hacks, then the answer might be that the best travel hack would be doing proper research and planning a perfect trip that suits your need. So there is a question and there is an answer. What are the best travel hacks? The best travel hack would be doing some proper research and planning a trip that suits your needs. So we generate a lot of these question and answer pairs, and so we generate a lot of answer pairs that can be generated using Twitter, Quora, Reddit, Yahoo Answers, and so on. So now you have scraped all of these four sites, and there are a lot of questions that you have generated. And let's see now what are the challenges that comes. What makes an index a good index, right? So index in many ways define the personality of your AI, right? Um, what difference do you find in these two indexes? Anyone wants to take a guess? So on the left hand side, there are a lot of Indian kind of things, like when somebody is saying "I love chatting," and they are saying "Have you got Natasha on hike?" Someone saying "My phone battery rocks," and someone is saying "Oh, must be Micromax mobile battery kebab." So clearly, on the left hand side, there are topics that are about um, India, like there are Indian topics like Micromax and Manmohan Singh and Natasha and so on. On the right hand side are things like NFL teams, language which is not really used by Indians like Na, um, and those kind of things. So I think the index, what kind of question answer pair goes into the index are very essential in understanding the quality of index. What personality would you respond with? So these answers are the ones that will be finally shown to the user. So where are these answers fetched from is very important. Um, so as I was saying, the source of data affects the language a lot, and it is important where this data is mined from. So we try and mine a lot of data from those things which are Indian, um, and that brings in a lot of personality which is Indian. Another aspect of a good index is that it should have a lot of data, like lots and lots of data. There are few reasons for that. First of all, more the data that we have, uh, more data that you will have, you will be able to answer more queries. Like for example, consider this tail query. What will you do if I give you 100 rupees? Um, Now this is a very kind of like a tail query, something that may or may not be there. But if you get more data, there is a likelihood that you might have something similar uh, to this query. So in this example, like bot might say that, oh, I will buy ice cream for you and me. Um, Again, if there is more data, the same query can be responded in diverse way. So for the query, I am sad. One response could be, "Don't feel sad. What happened?" Or it could also be, "Why? Just fight back." Um, so again, more data. There are different diverse ways in which the query can be responded. But how much data is enough data? Is 100 enough? Is 1,000 enough? Is 10,000 enough? Um, so we don't know, right? I mean, Brew uses like millions of query answer pairs to respond, and that is not good enough either. We continue to improve the index. The last aspect of a good index, which I wanted to cover, is having clean responses. So you should filter out those responses which might be considered bad, like for example, adult words, right? You don't really want to have adult words being spoken as responses. You don't want racist responses. You don't want any response which would kind of hurt the sentiments of people. At the same time, you don't want responses that kind of relate to some person. Like we said that we mine data from Twitter, Quora, Reddit, Yahoo Answers. So you don't want phone numbers, you don't want emails from those sources to show up as responses. You don't want rude responses. Um, so like go away, I don't want to talk to you, and those kind of things. So I think like the a very simple process of finding QA pairs from internet and mining them is the first aspect. That is step one. But then you need to do a lot of cleaning and filtering on top of it to ensure that the kind of responses that you want your bot to provide um, is what so the kind of responses that you want to provide is what your index contains. So you will have to clean them up. You will have to really take those sources which have an Indian feeling to it if you are creating an Indian bot and so on and so forth. So that is what a good index would consist of. A lot of data, clean data, and data which kind of reflects the personality that you have. So let me just look at some of the comments and try to answer some of those. Okay, cool. So let's move forward. So now let me talk a little bit about the ranker. Like, how does the ranker work? Um, um, I will talk about a deep learning model called DSSM. I do recognize that this might be a little difficult to understand. I'll try to kind of explain that in layman term, but it may or may not be easily understandable. So ask me questions if you have. So a DSSM, or Deep Structured Semantic Model, is a two is a pair of two neural networks. One represents question and the other represents the response. Um, so there is one network through which the question passes and the other network through which the response passes. So in the previous slide, we learned that how to create like a QA pair index. So we have like a, let's say we have a large QA pair index, which is question and answer pairs. So for how are you, there's I am fine. How do you do? I'm fine. Where do you live? I live in Hyderabad. Where's your home? In Hyderabad, and so on and so forth. So there's a huge index that is of QA pairs. So you pass Q through one neural network and you pass A's through the other neural network. So that is how you pass these to train. And then what the network tries to learn is that how do you match the it tries to learn to maximize the match between the two representations for relevant QA pairs. So when you say for how are you, you pass in I am fine. When you pass how are you and I am fine through the network, what you will try to learn is that they should be very similar to each other. The cosine similarity between the two vectors for how are you and I am fine should be very high. On the other hand, when you pass pass on something which is completely irrelevant, like for how are you, I live in Hyderabad, then the vectors would be very apart and the cosine similarity would be low. So this is what the network tries to learn. You pass in a lot of QA pairs, and then those QA pairs which are which correspond to each other, like for a given Q and A, then it tries to learn vectors in a way that the cosine similarity is large, and for those Q and A pairs where Q and A are not corresponding to each other, it tries to learn that they should be far apart of each other. So that is what DSSM essentially tries to learn. It's a deep learning model which, for a given query, tries to, for a given query and an answer pair, tries to say whether or not an answer is a right match for a given query. So that is essentially DSSM. Um, any questions on DSSM? I would like to know, and then I can answer those questions. So some people are asking what kind of AI technology could be uh, uh, made using Java. So I think like all languages, it's the algorithm that is important. All languages kind of can be used, not necessarily uh, uh, not not necessarily any language in particular. So so someone is asking how does it get value for the cosine? How is the cosine similarity implemented? So cosine similarity essentially is the dot product of two vectors divided by the norm or the absolute value of the two vectors multiplied. So read about cosine similarity on internet. Um, I I don't have it on my slide, but the cosine similarity essentially is the dot product of the two vectors and the distance and the norm divided by the multiplication of two norms. So when the cosine similarity is high, that essentially means that the uh, the kind of the angle between the two vectors is very low, and hence they are close to each other. And when the cosine similarity is low, that means that the angle between the two vectors is high, so they are kind of like apart from each other. So someone asked that how does the model learn that what things are similar to each other? So in the model, like when you pass a lot of training data, what it has is that there are a lot of question answer pairs. So you're passing a question and answer pair, and what it is learning is that for this question, this is the right answer, and hence the feedback is that the vectors should be close to each other. Now, for the same question, when you fire some random responses, then for those responses, it tries to learn that it should be far apart from each other. So that is what it tries to learn always. Like it tries to learn that those QA pairs which are in the training data, for them it needs to create like a index which is close to each other, and for those which are random, it tries to learn that the vectors should be far apart. And when you do that over like a large pair of data, large number of data, then it becomes like um, it kind of learns eventually. So someone asked, why do we need DSSM if we already have QA pairs, and how accurate is this method? So this method it gives us about 80% accuracy. So that is that question. Why do we need QA pairs? The reason for that is that let's say you have like 20 million QA pairs in your index, but you still will be able to ask questions which are not there in your index, right? You will ask a question which may not have ever been seen in your index. So you cannot necessarily just pick a QA pair and then give the response because you have not seen that QA pair. So what you want to now do is find that response um, which is closest to the question that is being asked, and hence we need DSSM, even though we have lots of QA pairs. Okay, can we build this more questions? So someone said that can this be built using entity extraction and intent classification? Yes, of course. The only challenge would be that when you're building a robot which can answer a lot of questions, like anything at all under the sun, then you don't have an intent classification, or you don't know what all entities are there in the world. So just to give you an example, like Shah Rukh Khan can be called in so many different ways. Someone can say King Khan, someone can say Shah Rukh, someone can say Khan, and there are so many different ways in which it can be said. So the method of understanding entities and understanding intent is kind of works well when you are creating algorithm for a particular domain, let's say finance or let's say movies. Then you know what are the type of entities that you are going to expect, and there the entity and intent works better. But when you're building a generic algorithm that can answer a lot of generic questions, then it is going to be very difficult to kind of understand um, the um, it's going to be very difficult to understand the intents and entities for everything. So a lot of people are asking how is the feedback given. So the training data has QA pairs which have been mined from internet. So we assume that for those QA pairs which have been mined from the internet, for a given Q, the answer is the right answer, and that they should the algorithm should output in a way that the cosine similarity for those two pairs is same, and then we take a lot of random answers for a given q, and we assume that the random answers for a given q are not the right answers, and hence the algorithm should put them far apart. So this is how the feedback mechanism works. You will start with a random initialization. So you will have random vectors in the beginning. You will do its cosine similarity, and then even for QA pairs which are truly QA pairs, you might have like a, cosine score which is low and the vectors are far apart. So then what you try to do is you try to change the vectors and pass on the feedback in a way that the vectors come closer to each other. So um, that is how the feedback works. Now someone is asking how to find closest question to be answered. That's a good question. So there's a step which I kind of skipped for the sake of simplicity. So first of all, we do like a keyword match. So let's say if you are doing if you're saying how are you, then we'll do a keyword match and get a lot of questions like how are you doing, how are you today, and those kind of things. So you'll get a lot of like similar questions. um, so that will reduce the set of questions that you need to further rank, and then you will rank giving the original question and the responses, the set of responses that came in. So a bunch of responses will be there. You will essentially rank each of that response against the original question that the user asked. So if user said how are you today, then you will rank I'm fine, or I live in Hyderabad, and all those uh, answers against that, and that is how you will. Someone said that, so it actually works only on saved QA pairs. So let me try to explain it again. So the algorithm has been trained. Once the algorithm has been trained for any given new queue, the answer which is already there in the index can be fetched, and the most correct answer would be given output. So let's say that you only had how are you in your index, but then somebody said how are you today. Then what the algorithm will learn is that how are you today is I am fine is a good response for even how are you today, because how are you today and how are you are cues which are close to each other, and hence the response I am fine is okay for q. So that is how it works, Shivank. Like it doesn't only work on the training data; it also works on any new set of questions that you might ask, which are not there in the index. So it would have learned that I am fine is a good response for how are you today, even if how are you today was not there in the index. Someone is asking how can your bot identify psychology of users by reading words only. So I talked about emotions earlier. So the way people kind of frame their sentence, the kind of things that they do, kind of indicates what kind of emotions do they have. And we can do a reasonably good job of understanding what the user is saying by understanding the words and the way the sentence is framed and so on. Any other questions? Okay, Shivank, thank you. So a lot of people also ask that how do they get started, right? I would really recommend um, starting with the Andrew Ng's course on machine learning. I think that is a very good starting point. Machine learning is a good starting point to understand the concepts of determinism versus non-determinism, and so on and so forth, and get your basics right, and then you can jump into deep learning and AI. So that is how I would recommend. I would recommend that you start with end-to-end G-scores. So Hardik, I don't understand your question. How is it gonna learn? Can you elaborate? Uh, so Gagan talked about if there's a mismatch, then what will happen? So when there are lots and lots of questions in your database or in your index, um, you would hope that one of the questions would be closer to the question that the user asked, and there will be less and less mismatches. Um, so I think I hope that answers your question. That when there are lots and lots of questions, then you perhaps would not have mismatch. I will type in the course that I recommended. I would recommend you to try out the Andrew NG course on machine learning. So some people ask, what is the scope of AI in um, India, right? So I think like AI is definitely going to be the next generation technology. Uh, Almost everything would have AI inbuilt, and we are already seeing AI impacting agriculture, AI impacting l- banking. A lot of decisions are becoming possible today because of AI. So AI will continue to be the future, and we will see accelerated growth of AI in India, and how different systems in India would grow by using AI. So in terms of scope, I think definitely this is going to be something which is the future of, right. Some people talked about your use of GPU for DL. When you have a large amount of data, yes, GPUs definitely help. Today, now you can rent a GPU from um, HR as well. So you don't need to buy. You can rent a GPU for a few days and run your experiments, and so on and so forth. Um, Someone asked how is it going to update its knowledge. So that goes back to the question of personalization. As I said in the beginning of the talk, that there are two aspects. One aspect is around memory, and the other aspect is interpretation of memory, right? So uh, you basically start off by trying to understand what kind of events are important. So, is age important? Is date of birth important? And those kind of things, and try to store that. So that is one aspect. The other aspect is what was the mood of the person when they last talked to you. What kind of entities did they talked about when they last talked to you, right? So those kind of things you will try and kind of store, and then use those things later on when the user comes back again, and try to ask questions which are related to that, and so on and so forth. So that is how I would think that it would happen. Um, some people are asking about they want to make a simple AI. How can I help? Um, I'll recommend something called Microsoft Bot Framework. I am going to type this in, Microsoft Bot Framework. Using Microsoft Bot Framework, you can create a very simple bot and hook it up to, let's say, Facebook or um, um, Skype or any of the choice of your agent. and that way you can start by creating a small robot that will do things that you want to do. Um, there are a lot of small code samples and snippets of code that will help you. So try out Microsoft Bot Framework for anyone who wants to start building a bot. I would recommend that just try Microsoft Bot Framework in the beginning, and that should really help you get started. So I think like some people talk about what all can AI do. I think AI can do anything that we train it to do, right? If you would train it to uh, cook, then it will be able to cook. How do we cook as humans? How do we cook? We have bunch of ingredients. We have some ratio in which ingredients can be mixed. So um, like you given a lot of sample, a lot of data which talks about what kind of ingredients to be used, in what ratio to be used. It can definitely use learn to cook as well. So that is how I think that is how I think about what AI can do. I think AI can do whatever we teach it to do. Like for example, you saw that Roo can paint. So definitely like. Who can paint, and it has learned how to paint. So that is how. So I think I'll move forward now. I would recommend you to learn that. I think one question which I was hoping somebody would ask, but they did not ask, is that how do you give textual input to a neural network? How do you convert a textual input into a vector or a real number and give that as an input in neural network? So try to think about it and learn how can you do that. Then also try to learn more deeply about DSSM. That will really help you. I would request feedback from you guys. So I would appreciate if you can go to do and type hash awesome if you like the session, and blah if it was not so good. It really helps improve for future. So thank you all for attending the session. I will be around for another 10-15 minutes to answer any questions that you might have. Um, uh, Go try out Roo at facebook.com/Roo. And we also published a story of Roo, how we kind of went around building Roo. You will be able to get link to couple of papers here, which talks about some of our technology in more detail. I also pointed out some of the useful APIs that Microsoft has so that you don't have to start from scratch. So like for example, we have a semantic text analysis API which give you what is the sentiment of the query, right? So those kind of things. So um, then there are vision APIs which will tell you that whether what is the age of a person, whether the person is a male or a female, and those kind of things. So try out these APIs in your school projects or in your college projects and see how you can use them and make fast progress on some of the scenarios that you are working on. And I will be around for next 10-15 minutes to answer questions on the chat. Okay, so thank you everyone, and I will be around. So some people are asking what are the prerequisites for learning AI and machine learning, right? Um, so I think as I said that try out start with the Andrew NG course for machine learning, and that would be a good starting point. There are You just need to be able to think like a human being, and think how will you as a human solve the problem. And I think that is what will help you understand how to deal with the problem at hand. So I think there are two important aspects. One is having the right set of data, and then having a mechanism to, in a way, um, learn features like, let's say that you're trying to cook, right? I mean, we took the example of cooking earlier. So what kind of ingredients would you use? That would be some feature. What kind of in what ratio would you use would be some features, and so on and so forth. I think some people wanted to look at the URL, so I am going back to the slide where the URLs are. I think this video will be available after a while, and or you can just take a picture of these on your screen. That way, it would be helpful. Okay, guys, thank you so much. I think that will be it. I'm signing out for now. So, thank you so much.